Okay, sorry. Today we are going to start with the first order differential equation. That means for the first order differential equation means we are dealing with the equation involved with the first differentiation. For example, just like this. We are going to solve dy by dx is equals to x plus 2. Such occasions we are going to deal with. Other than that, or you can say dy by dx it's equals to x over y plus 2 or somewhere around here, whatever. It's in only the first differentiation that is called the first order differential equation. Let's try to understand from one simple equation example and try to start with the how to solve this differential equation. When they request for this kind of question, I will try to explain from here. They might give you dy by dx. I'm starting with this one. It's equals to x plus 2. Part A, they can ask you find the general solution. Find the general solution. That is part A. Part B, they can ask you find the particular solution. Particular solution. Solution if the curve passes through through 1, 2. Right. Let's go ahead with this answer. So we need to solve this equation. Dy by dx, part A, I'm going to do it. It's equals to x plus 2. Now the first step is bring this dy and dx in numerators and keep the x variable in one side and y variable in the other side. You have to, what you need to do is you have to separate the variables into two sides of this equal mark. There is nothing, no y involvement here. You can bring this x plus 2 to this side. It's here. Right. Then integrate the both sides. Dy it's equals to x plus 2 integration dx. Then you can understand that this dy means it's 1 into dy. Right. Therefore, if you integrate d1, answer is y. It's equals to integration of x is x squared over 2 plus 2x. We can add a constant to any of the side, doesn't matter which way you use it, right? Because since it's y equals, then we can generate y equals something. Therefore, I just add this c to this side. So this is the general solution. General solution means we are finding an answer as a general fact. There is some kind of a constant adjoined here. With this particular values of c, you can find different answers. If they specify a value for c, that solution we call it as a particular solution. So this is a general solution. To find the particular solution, what you need to do is we need to find the value for c. Then the answer is particularly gone through following up certain limitation. So it's passing through 1, 2. That means when x equals to 1, y value is 2. So therefore you can say 2 equals to 1 squared over 2 plus 2 times of 1 plus c. With that you get the answer. C would be minus half. Therefore you can find the particular solution y equals to 1 over 2x squared plus 2x minus 1 over 2 would be the final answer over here. That's a way of getting this answer. Yes, the question is dy by dx is x squared plus 2 over y minus 1. The question is find part A, general solution. Right. Part B, particular solution. Yup. Particular solution if it satisfy part 1 x equals to 1 with y equals to 2, part 2 x equals to 3 with y equals to minus 4, somewhere around here, right? Okay, we'll try to get the answers for this question. Initially we can say dy by dx, I'm starting with part A, it's equals to x squared plus 2 over y minus 1. Bring this dy and dx at top and separate the variables, x terms into one side and y terms into other side. Then integrate both sides. It's 2 dx, right? So in this case, if you integrate y plus 1, answer is y squared over 2 minus y equals to x cube over 3 plus 2x squared over 2 plus c, right? Then we can say y squared over 2 minus y, it's equals to x cube over 3 plus x squared plus c. This is the general solution. Depends on c, it can be converted into particular solution depends on this boundary condition. So this is the answer for part A, right? Part B, first particular situation, it's when x equals to 1, y become 2. Therefore you can say equation y squared over 2 is 2 squared over 2 minus 2 equals to 1 cube over 3 plus 1 squared plus c. So with that, c turn up into 2 squared is 4, 4 minus it's 2, it get cancels here, it's 4 over 3 minus 4 over 3. So this particular solution turn up to y squared over 2 minus y equals to x cube over 3 plus x squared minus 4 over 3. That's the answer for that particular situation, right? Part 2 is when x equals to 3, y turn up to minus 4. It's turn up to minus 4 squared over 2 minus 4 equals to x cube. X cube is 3 cube over 3 plus 3 squared minus, plus c. Right. So over here it's 16. 16 divided by 2 is 8 plus 4 equals to 9 plus 9 plus c. So with that, c turn up into 12. 12 minus 18 is minus 6. So this particular solution is, I will write it here, y squared over 2 minus y equals to x cube over 3 plus x squared, c is minus 6. That is that particular solution for that specific boundary condition. Let's go to another question. They might give you a question like this. Dx over dt, it's equals to sec squared t. I will get a kind of an easier question for the beginning. Then after that we can go ahead with that. Sin t over, we will get cos x. Cos x. They might give you, right, when x equals to pi by 3, t turn up to pi by 4. The question is straightforward. Since they are given the boundary conditions, the question is find the particular solution. Find the particular solution, right? Okay, that's a simple fact we need to work out, right? Same way we can work out dx over dt, it's equals to sin t over cos x, and bring this x terms to one side while keeping the dx and dt at top, sin t dt, then integrate the both sides. Then what do you get? Cos x integration. What is the integration of cos x? It's sin x. It's equals to Sin t integration is minus cos t. You have to add a constant over here. This is a general solution. If you want to find the particular solution, we have to specify with these particular values. So x is pi by 3, whereas t is pi by 4. So answer is sin pi by 3 equals to minus cos pi by 4 plus c. So this answer turn up to sin pi by 3. It's root 3 over 2 equals to minus 1 over root 2 plus c. With that you can write c equals to root 3 over 2 plus 1 over root 2. So you can get the LCM. 2 root 2 is root 6 plus 2 equals to c. So with that you can write sin x equals to minus cos t plus root 6 plus 2 over 2 root 2 is a final answer. This is the particular solution which satisfy this first order differential equation. Right. The next topic is you can get dy by dx plus py equals to q format. That means you happen to find this differentiation. They ask us to solve this differentiation. X cube dy by dx plus 3x squared y equals to sin x. Right. Then I will ask a simple question. If you want to differentiate this function, any function fx, into y, what would be the answer? Keep fx and differentiate y, plus keep y and differentiate fx. That's the usual product rule where we need to know about the differentiation of fx into y. For example, if you happen to differentiate this one, x cube y, what would be the answer? Keep x cube and differentiate y plus keep y and differentiate x cube. So what would be the answer? X cube dy by dx plus y times of 3x squared. Now can you see this is the expression available here, isn't it? That is the expression available here. So you can simply look like this. I will use two different colors. Y, the differentiation is available here. And this x cube, see whether the differentiation is available there. Y, the differentiation, whether this term, the differentiation is available here, as well as see whether the differentiation of this is available here. In such cases, you can write, yes, this is the differentiation of x cube into y. It's equals to sin x. Y differentiation is here, whereas x cube differentiation is here. Therefore, y into this would be the total differentiation, that would be the final extent of it. Then in such occasion, integrate both sides. X cube y equals to integration of sin x. Now you can see this whole function. I'll use another bracket to show this clearly. This whole function is differentiated and then integrated. Then what happened? You have done the forward operation as well as you reverse that process. So in that such occasions, what you can say, you can cancel out this integration with differentiation. Actually, it's not cancelling out. Don't misinterpret with that. That is the some kind of a function we take and you differentiate it and you integrate it. That means you have done the forward process and you have done with the reverse process. For example, 3 plus 5 minus 5, like that operation. So it come up to the initial amount. So this is turn up to x cube y, it's equals to sin x integration is cos x plus c. This is a general solution. If they are given particularly some boundary conditions here, then substituting with that you can get the particular solution for this kind of question. That is how you need to answer this kind of questions. Right. Then they might give you a question. Solve sin x dy by dx plus cos xy, it's equals to we will get sec squared x, right? Then rather than that asking solve, it's better to write find the general solution for. This is part A. Part B, they can ask you hence find the particular solution at x equals to pi by 3 and y equals to pi by 2, somewhere around here. So you can work out, you can find it. Just we'll go ahead with this, right? Then you can see sin x dy by dx plus cos xy. Now you can see this clearly. Differentiation of y is here. Yep. Therefore, you can write y. Differentiation of sin x is here. Therefore, you can write this is sin x. So, in this sense, you can write this is the d by dx of sin x y, sin x into y, it's equals to sec squared x. Then you can integrate the both sides. D by dx of sin x into y equals to integration of sec squared x. So this whole function is differentiated and integrated. Therefore, it's turn up to sin xy equals to sec squared x integration is tan x plus c. This is the general solution. To find the particular solution, what you need to do is you need to find this substitution and you have to find the particular equation for this differential equation. So you can say sin x, x is pi by 3 into y, y is pi by 2 equals to tan pi by 3 plus c, right? Then you can say sin pi by 3 is root 3 over 2. Root 3 over 2 into pi by 2 equals to tan pi by 3 is root 3 plus c. Therefore, c is turn up to root 3 pi by 4 minus root 3. It's equals to c is, if you can keep it as it is here. So you can write sin x into y, it's equals to tan x plus root 3 pi over 4 minus root 3. If you want, you can subject y. It's equals to tan x plus root 3 pi by 4 minus root 3 divided by sin x would be the particular solution of this differential equation at these conditions. Yes. Then let's go ahead with this question, Pate. They might ask you to solve, find the general solution for dy by dx plus 3y over x equals to sin x over x cube, right? Is the fact we need to find it. Now you can see the differentiation of y is here, but the term over here, if you differentiate it, you can't get the answer over here. So always we don't see the kind of questions where we meet at the previous types. So all the time you don't see that kind of exactly the proportion of y differentiation available in the other side, and other side proportion is exactly available in the what do you call as a second term. So this is not practically happen. So can we make this expression into that previous type? Let's see. I want to make dy by dx plus 3y over x equals to sine x over x cube. Then I'll multiply this entire expression with x cube. So what do you get? X cube dy by dx plus, if you multiply with this x cube, is 3x squared y. It's equals to sine x. Now you can see this condition. The differentiation of y is available here, and differentiation of x squared is available, sorry, x cube is available here. Therefore you can write this is d by dx differentiation of x cube y. So with that you can say this is equals to sine x. Then you can integrate the both sides, turn up to x cube y is minus cos x plus c. If you want, you can write y equals to minus cos x plus c over x cube. Now our doubt is, I just randomly multiply with x cube and form this equation, but all of the time we may not able to find from which number or to divide from which number we need to make it if you want to get this equation in type of this. So that is not practical. Just looking into the equation, you cannot see whether from which number we have to multiply or which number you have to divide, so on, to form into the equation into the previous format. That is what we need to learn in our next level. Now we have to form a general format to solve above type of equation. So if you happen to see a question like this, solve the general solution for dy by dx plus py equals to q, where p and q are functions of x, are functions of x. There's a particular type where we need to solve this equation. These ones are just like some kind of different examples, like our previous example, just like sine x, x cube, somewhere around here, right? This is the way of doing it. Initially, this is the way of understanding this question. I will write this way. This is what we need to solve, plus py equals to q, right? Then I will multiply this equation with a term called integrating factor. Later on you will understand what I mean by integrating factor, don't worry about it. Multiply by integrating factor fx, and we learn how to find the integrating factor later on. Just don't worry about it, just make it as it is. Therefore it's turn up to fx dy by dx plus p fx y equals to fx q. Then according to the former procedure, this fx dy by dx plus p fxy, if you want to convert into the previous format, it should be in this way. It should be similar to just like this, fx into y plus, sorry, fx into dy by dx plus f dash x into y. According to this one, this part is fine. Therefore p fx should be similar to how much, Pute? F dash x. Therefore p fx should be similar to f dash x. That is the fact we need to understand over here. Then I will do it in this way. I'll just keep this p this side and I'll bring this fx to other side. Then I'll integrate the both sides. Don't worry about what I'm doing over here. It's integration of f dash x into fx. Then we know that this condition, we know that this condition, if any function, if there's a fraction and if the denominator power is 1 and its differentiation is the top, you can straightforward write the integration for this one is ln fx. You can write it exactly. If you can find a fraction where the power of the denominator is 1 and its differentiation is at top, we can straightforward write the integration over here is ln fx. We put a modulus because to say fx does not exist for negative values. That is the integration of p. Then you can write fx is equals to bring this ln to other side, turn up to e to the power integration of p. Now you can understand I got in fx as integrating factor. Therefore you can write integrating factor would be always e to the power integration of p. Still it's a little bit of doubtful, I know. Don't worry about it. From a question I will make it much simpler and I'll make it much understandable to find how to find the proper integrating factor and how to do this kind of a question. So in that sense you can easily find the solution for this kind of equation, but rather than that doing as a theoretical concept using an what do you call practical answer, some kind of like question explaining this answer would be much appropriate and easier, right? I will explain from a question. For the moment you just copy down this note. Yes, let's try to understand from a question. Here let's see, we need to solve dy by dx minus 4y equals to e to the power x. We need to find the general solution. If they are given the boundary condition, we can find the particular solution. Now you can see the difference. So to apply to the former the previous format, you can see clearly understand that here the number should be 1. That is quite important. It should be 1. That is quite important when you are working out with this. Therefore now you can see here the value is 1, right? Then you can see the differentiation of y is here. So from this term isolate this y. If you isolate y, what would be the remaining term? The remaining turn up to minus 4. Therefore you can write integrating factor. Integrating factor. So how do you get this integrating factor? From this example, if you isolate this y, sorry, just isolate this y, sorry, if you get like fx into y, that would be the like over here, if you isolate y, the rest of the term would be the integrating factor, right? Okay, so what you can get here is we can find it as the integrating factor as integrating factor is e to the power integration of how much? Integration of minus 4. This would be the integrating factor. Minus 4. Then that is turn up to how much? E to the power minus 4x. We won't put plus c for this expression. So you can just write e to the power minus 4x. Then how do you supposed to solve this? Then multiply this entire expression, all of these terms with this integrating factor. That's a way of doing it. You just multiply with e to the power minus 4x. Let's see what you get from here. So it's turn up to e to the power minus 4x dy by dx minus 4 times of e to the power minus 4xy equals to e to the power minus, so e to power x, e to power x into e to the power minus 4x. Now let's see, this has turned up to e to the power minus 4x dy by dx minus 4 e to the power minus 4xy equals to e to the power minus 3x. Right. Then now check whether this condition satisfy. Differentiation of y is here. Not a problem about y. The differentiation of e to the power minus 4x is how much? That is turn up to minus 4 e to the power minus 4x. Therefore, you can write this is e to the power minus 4x. That means this is the total differentiation of this. That is the format where we want to make. That is why we just multiply with this integrating factor. It's equals to e to the power minus 3x. Now what are we supposed to do? We have to integrate the both sides. d by dx of y e to the power minus 4x equals to integration of e to the power minus 3x. So this whole function is differentiated integrated. Therefore, it's turned up to y e to the power minus 4x. It's equals to, if you integrate e to the power minus 3x, answer is minus 1 over 3 e to the power minus 3x plus c. If you want, you can write y equals to minus 1 over 3 e to the power minus 3x plus c divided by e to the power minus 4x. Or you can write y equals to minus 1 over 3 e to the power, if you bring it up, e to the power plus 4x, turn up to e to the power x plus c e to the power 4x is the final answer for this. If you know the boundary condition for this differential equation, you can find the particular solution. Understand that you have been getting a general solution for this kind of question. Find the general solution for dy by dx plus 2xy equals to e to the power minus x squared. Now you can see here the differentiation of y is here. Not a problem here. To apply to the previous format, now check whether is there any term here is 1. The differentiation of 1 is not 2x. Therefore, you cannot write d by dx of some kind of a whole function. It's not possible of writing like this. To get rid of this situation, and we need to form into this kind of a equation, dy by dx of whole thing, then only you can put integration for both sides and do it. Then how to avoid this situation? Anyway, you need to form into that format to obtain this answer over here. To make it, I can find the integrating factor called if, integrating factor. To find the integrating factor, anyway, this number should be 1. Here the number should be 1. It's obviously 1. There was nothing to worry on that. Okay, we will do some kind of cases where that factor is not equal to 1. But for the moment, don't worry. Then from the other term, join with this dy by dx, isolate y. What would be the remaining term? Remaining term is 2x. Therefore, you can write integrating factor would be e to the power integration of 2x. Right. What would be the integration of 2x? E to the power x squared. Right. Now multiply this whole expression with this integrating factor. Now let's see what happens if you multiply with integrating factor this whole expression. E to the power x squared dy by dx plus 2x e to the power x squared y equals to e to the power x squared into e to the power minus x squared. Right. Now check whether, now you can see whether can we form the previous format. The differentiation of y is here. So y you can replace here. Then what can you say about differentiation of e to the power x squared? It is this answer, right? Therefore, you can write this is e to the power x squared. That means you can write this whole thing is the differentiation of this expression. It's equals to, if you simplify this, you can add these two together, e to the power 0, it's turned up to 1. If you simplify this, e to the power x squared plus minus x squared, it's turned up to e to the power 0, it's turned up to 1. So now you can integrate the both sides. Okay, right. Then this is whole thing is get cancels each other. Turn up to e to the power x squared y. It's equals to integration of this is in terms of x is turn up to x plus c. Therefore, if you want, you can write x squared y, because you have to subject y anyway, ln x plus c, then y equals to ln x plus c over x squared is the answer for that. Okay, now right, if it is not 1, what are we supposed to do? Dx plus 2y sin x equals to cos to the power 4x. So divide this whole thing by cos x to make them into 1. So divide by dx is equals to 2y sin x divided by cos x. It's how much? Tan x. It's equals to cos to the power 4x divided by cos x is cos cube x. I just divided all of these terms by cos x. So now this value is 1. If you isolate y, what is the remaining term? The remaining term is 2 tan x. The remaining term is 2 tan x. Therefore, what happened with it? Integrating factor. What is the integrating factor? E to the power integration of 2 tan x. Okay, right. That is e to the power integration of 2 tan x integration is how much with it? It's turn up to if you integrate tan x ln sec x, we can make like that, ln sec x. Right. If you want, you can take this 2 in and you can write e to the power ln sec squared x. You can bring this 2 in as a power of sec x. So this is the fact. Now what you need to do is integrate this entire expression, this expression, with ln sec squared x. Ln sec squared x dy by dx plus 2 tan x ln sec squared x 2 tan x ln sec squared x y, it's equals to, sorry, I just made a mistake here. It should be this way, 2 tan x e to the power ln sec squared x y, it's equals to e to the power ln sec squared x into cos cube x. That's a fact we need to understand over here with it. Right, okay. Now let's go ahead with this, the simplification. Yep. Then here, this is e to the power ln. Then what you can understand here is with the e ln. Just take your calculator and check whether what is the answer for e ln 2. Let me the answer for this. What is the answer for e ln 2? It's turned up to 2. E ln 100. Check whether it's 100. Therefore, instead of this term, I can straightforward write ln and e. It's not cancelling. Ln and e are just like the opposite and so opposite operation. You're doing forward and backward operations. Turn up to sec squared x dy by dx. It's plus, this is turn up to 2 tan x sec squared x y. It's equals to sec squared x cos cube y. So it's turn up to sec squared x dy by dx plus if you simplify, you just keep it as it is, 2 tan x sec squared x y. It's equals to sec squared x is 1 now, cos squared x turn up to sorry, this is cos cube y. Yes, it's turn up to cos x. That's the answer where we get it with it, right? Then we can see, now look at this, the differentiation of y. If you form it, you should get this answer. Differentiation of y is how much? Dy by dx. So therefore it's y. Differentiation of sec squared x is how much with it? Just work out and see, you will understand it's turn up to 2 tan x sec squared x. It's turn up to then, this is the sec squared x. When you multiply with integrating factor, nothing to worry, it should be, you should get the answer in form of this. That's obvious fact. It's equals to cos x. Then integrate the both sides. Then what you get here is, that is sec squared x y, it's equals to integration of cos x is sin x plus c. Therefore y is equals to sin x plus c divided by sec squared x is the final answer for this question. That's how we come up. Let's go ahead with this question. X dy by dx plus y, it's equals to cos x. We need to solve this equation, find the general solution, right? Then before we go ahead with this, you can see the differentiation of y is here and differentiation of x is 1. It's here. So obviously nothing to worry with any integrating factor or anything. You can straightforward, this is d by dx of x into y. It's equals to cos x. Then you can integrate the both sides. Then that is xy, it's equals to sin x plus c. Y turn up to sin x plus c over x is the answer for this. That's a way of doing this question, right? We'll go ahead a little bit further. Another question, e to the power minus x dy by dx minus e to the power minus xy, it's equals to x e to the power x. Now check whether the differentiation of y is here and differentiation of e to the power x is here. So obviously nothing to worry with integrating factor, straightforward. You can add this differentiation of y e to the power minus x. It's equals to x e to the power x. Now you integrate the both sides. If you integrate this side, nothing to worry. This is y e to the power minus x, but here there is a issue. X e to the power x. This is a product of two different functions where the differentiation of this is not available here, and there are two different types of function. Therefore you have to go ahead with integration by parts. Therefore you have to pick u as the function which is simplified at the differentiation. Therefore du by dx, we learned this topic in previous lessons. Therefore I'm not going to extend that one. Hope you can remember this. dv by dx is e to the power x. Therefore v is the integration of e to the power x is e to the power x. Formula is uv minus integration by v du by dx for the integrating by parts. U is x e to the power x minus integration by e to the power x into 1. It's turn up to x e to the power x minus e to the power x. So y e to the power minus x is equals to x e to the power x minus e to the power x plus c. So you can write y equals to x e to the power x minus e to the power x plus c over e to the power minus x. E to the power minus x. If you brought it up, it's turn up to plus x, e to the power plus x, so turn up to x e to the power 2x minus e to the power 2x plus c e to the power x is the final answer for this question. Then the next question is, they might give you part A, find the general solution. I just write short form general solution for x squared dy by dx plus 2xy equals to 2x plus 1, right? Part B is find the particular solution for 1 minus 3, right? We'll go ahead with this. So what you need to do is, initially I'll just start with this question. I just copy down this integration the first order differential equation here, turn up to 2x plus 1. Now check whether the differentiation of y is available here. Yeah, it's fine. Differentiation of x squared, yeah, that one also here. So nothing to worry about this integrating factor. You can just write this way. Sorry. D by dx of this, it's equals to 2x plus 1. Then you can do the integration for both sides. Turn up to x squared y is equals to 2x integration is x squared plus 1 integration is x plus c. Therefore y is turn up to x squared plus x plus c divided by x squared. It's turn up to 1 plus 1 over x plus c over x squared. It's the general solution. Then if you come out with a particular solution is 1 minus 3. So it's satisfying. The y value is minus 3 equals to 1 plus 1 over 1 plus c over 1 squared is 1. So it's turn up to c equals to minus 5. So you can write y equals to 1 plus 1 over x minus 5 over x squared would be the particular solution for above first order differential equation. Okay. Yeah. Okay, then we'll go ahead with this. It's equals to, you'll get 1 over x plus 1, right? Okay, then they have given yeah, find the general solution. Find part A general solution, part 2 particular solution if 1 minus 1. Right, we'll go ahead with this for them. Right, then you can see if you start with this proportion ln x dy by dx plus y over x is equals to 1 over x plus 1. Now the differentiation of y is here, not a problem. Differentiation of ln x is here, it's 1 over x is ln x. Therefore it's turn up to d by dx of ln x times of y. It's equals to 1 over x plus 1. Then integrate the both sides. Turn up to how much? It's turn up to ln x y is equals to 1 over x plus 1 integration is ln x plus 1 plus c. Therefore y is equals to ln x plus 1 plus c over ln x is the answer. Therefore we can go ahead with the this is a part A. Then the particular solutions would be particularly at 1 minus 1, it's turn up to minus 1 equals to ln 1 plus 1. But this should be 2. One other than that you don't get the answer. 2 plus 1 plus c over ln 2. So it's turn up to minus ln 2 minus ln 3. It's equals to c. So c is equals to, yep. Yeah, that's the answer for that. So we can go ahead with y equals to ln x plus 1 minus ln 2 plus ln 3 divided by ln 2 is the final answer. That's how we need to get the answer for particular solution for this first order differential equation. This is the general solution for it. If you want to get this dy by dx plus 2y equals to e to the power x. So here the differentiation of y is here, but the differentiation of its 1, it's not available here. Therefore you have to find the particular integrating factor. Integrating factor is e to the power integration of, if you isolate y from here, the remaining term is 2. It's turn up to e to the power 2x. Right, then multiply entire expression with e to the power 2x. Now let's see, e to the power 2x dy by dx plus 2 e to the power 2xy equals to e to the power 2x into e to the power x. Now you can see differentiation of y is here and differentiation of e to the power 2x is here. So this is the whole differentiation of this. It's equals to e to the power multiplication turn up to 3x. So integrate the both sides. There you get the answer. Y e to the power 2x it's equals to e to the power 3x over 3 plus c. Then that would be the answer for this question. So if you want, you can say this is e to the power 3x plus c divided by e to the power 2x. So you can write y equals to e to the power x over 3 if you divide these two terms plus c over e to the power 2x, it is e to the power minus 2x is the answer for this. That's a way of getting the answer for this kind of a question. Right. Now, if you need to solve this kind of question, find the general solution for this 3x dy by dx plus y equals to x. Now, the differentiation of y is here, but differentiation of 3x is not available here. Therefore, I have to go ahead with the integrating factor. To find the integrating factor, this number in front of dy by dx should be 1. Therefore, I'll divide the entire expression with 3x. So the answer is dy by dx is equals to 1 over 3xy equals to x over 3x is 3, 1 over 3. Number 3. Then what would be the integrating factor? Integrating factor would be, if you isolate y from here, answer is e to the power integration of 1 over 3x. It's turn up to e to the power 1 over 3 ln x. So you can write this is, you can take this 1 over 3 in ln x to the power 1 over 3. So the e and ln get cancels, not cancels, actually simplify, turn up to x to the power 1 over 3. Therefore, multiply entire expression with x to the power 1 over 3. It's turn up to, then 3x into x to the power 1 over 3 is 3x to the power 2 over 3 dy by dx plus x to the power 1 over 3 y. Yup, it's equals to, yes, hopefully that is fine. Yep. Then it's turn up to x into x to the power naught is x to the power 2 over 3. Now there is a small issue seems to be here, but here the problem is like if you multiply 3x by x to the power 3 x to the power 1 over 3 is x to the power 4 over 3, 3x to the power 4 over 3. Then over here we just multiply y, like this is 3x. So this simplification is 3x to the power 4 over 3 dy by dx plus this is 1 over 3 x to the power minus 2 over 3 y, it's equals to x to the power 2 over 3. Yeah, so you have to multiply this entire expression with x to the power 1 over 3. I think I made a mistake. That is x to the power 1 over 3 dy by dx plus 1 over 3x multiplied by x to the power 1 over 3. So 1 over 3x, x should be in the denominator. Y equals to 1 over 3 times of x to the power 1 over 3. That's a fact. So if you do this, x to the power 1 over 3 dy by dx plus 1 over 3 x to the power 2 over 3 y, it's equals to 1 over 3 x to the power 1 over 3. Now you can see the differentiation of y is here, and as well as x to the power 1 over 3 differentiation is here. So you can write this is the differentiation of whole x to the power 1 over 3 times of y. It's equals to 1 over 3 x to the power 1 over 3. Yes, right. Then integrate the both sides. Then what do you get with it? Y x to the power 1 over 3, it's equals to 1 over 3 times of, if you do this, x to the power 1 over 3 plus 1 is 4 over 3 over 4 over 3 plus c. It's turn up to y x to the power 1 over 3 times of 1 over 4 x to the power 4 over 3 plus c. Then you can write y equals to, if you do this division, 1 over 4 x to the power 1 over 4 over 3 divided by 1 over 3 is x plus c x to the power minus 1 over 3, or c over x to the power 1 over 3 is the final answer for this question. So here we have to work out the particular integral. To find with the particular integral, this coefficient should be 1. That is the approach where we come across with this question. Okay.